Hello friends, welcome back. So I hope you have reviewed the previous lecture which was regarding your stacks, right? So I hope you have viewed that previous lecture wherein it was regarding your stacks. And friends, please don't watch this video without watching the previous video wherein we have discussed in detail what is stack organization. What are these stacks? Okay friends. So maybe I'll not go into revision once again because I have discussed in very detail in the previous lecture. So please watch that video. Now, to tell in continuation with the previous lecture, in stacks, we have two important errors. One is full error, the other one is empty error. Now, when this would occur, I hope you might have understood. Full error would occur when the stack is completely filled. You go on pushing, and your stack pointer will reach here. The full will be put to 1. At that case, if your user tries to put one other data, then what is the error you would be getting? The error you would be getting is full error. Right? So this is one error. The other error is your empty error. So when this empty error would come, this empty error would come in the case of pop instruction. That means you go on decrementing, you go on removing all the data, right? Once you go on removing all the data, where you reach at the bottom. Then again your user comes and tries to get one more data outside of the stack. Then he will find here nothing. At that case, your processor will pop up an error which is called as empty error. Right friends, so these are two important errors. If they ask in exam, you have to mention these two errors which are related with your stack. I hope this is clear. That is, one is full error and another one is empty error. Therefore we will be using two important labels here. For full error, in order to avoid full error, we will be having a label called as safe push, wherein you have to use, if the push is safe, then only it would be performed. That means it is called as safe push to avoid full error. To avoid empty error, we have one more label called as safe pop. Simple. That means safe push is considered whenever you are doing the push values, when you are trying to put the values, right? Safe pop is used whenever we are trying to remove the values, whenever we are using the instruction pop. So these are two important labels which are connected with two important errors, which are nothing but full error and empty error. Okay friends. Now in continuation with the previous class, so this slide has been already covered in the previous video. Today we will try to speak about your applications of the stack. That is, the main question which arises with our students is, why I should study this? What is the use of this? That means the first very important application of your stack is it is used by the processor. That means, or you can say by the user. Whenever, now why it is used by the processor, why it is used by the user is nothing but your next application. Okay, now there are n number of advantages of using a stack. The first advantage is, if I want to save the contents of the register. Say for example, you are doing some application wherein you are running some application. You are doing some addition, subtraction, multiplication, something like that. You are adding 10 numbers. In between, you will get an request to multiply. Then in that case, your processor should save whatever it is doing. Say for example, it has added only 5 numbers, but the task is to add 10 numbers. Then it has to save the contents of that 5 added numbers. Where it will save? In that case, it will use your stack, wherein it will save the intermediate result into the stack, go to perform that operation which has come, say multiplication. It will complete that multiplication and it will come back and add the rest of the 5 numbers. So therefore it is used to save the register contents. So this is our first application. Okay, now what is the next application, or how this could be? The other way to view this work is, say for example, you added the contents of 5 additions, you have saved in the stack. Now you want to retrieve it, then what I need to do? Again I have the stack, right? So if I want to save, what we are doing? We are using push instruction. If I want to retrieve it back, what instruction we will be using? We will be using the pop instruction. So I hope this is clear. Next is what now? If I want to find a link between the main program and a subroutine. Right now, I hope you don't know what is subroutine. Just imagine a subroutine as a function. Say a main program is running, and I hope the functions you know, all of you know the functions, I assume, because you already studied C in your basics. Okay. Say for example, a main program is running, right? A main program is running, and a function will come and distract the main program. Then what it has to do now? What it has to do? It has to save the contents of the main program. If it wants to save the contents of the main program, then where it will be storing? It will be storing inside the stack. Again, when the execution of the function is over, it has to come back and again execute your main program. In that case, again it has to retrieve from where it has stopped execution of the main program, and it has to continue. So therefore, if I want to store any main program and if I want to retrieve any main program, then I require my stack. So that's why it is used to form a link between your main program and the subroutine. Next is if I have any interrupt operations. I hope you have not yet studied these interrupts. With this you will be studying in your module number 3, which is very interesting and very important. Now, if you just remember what I'm trying to tell now. For any interrupt operation, your stack is like a middleman. He will try to resolve the things between the interrupt and your processor. Okay, so even when we are using your interrupt operations, we will be requiring our stacks. So I hope the stacks is clear till now. Okay, if you have any doubts, you can always contact me. Moving ahead with the next very important topic, which is queues. Queues is again very similar to your stacks. What was stacks? Stacks is nothing but it is a method to store the data. And how we are storing the data inside the stacks? In the form of an array or in the form of a list. Similarly with the queue also. In the queue also we will be storing the data in the form of an array or in the form of a list. Here also your data is arranged in the form of a queue. That means your memory is also arranged in the form of a list or in the form of a queue. I mean to say it would be something like this. It would be something like this. This is what we have seen in your stacks. That is, your whole memory is again arranged in the form of the queue. So this is what we saw in the stacks. That is, there was a queue, there was a list like this. We would put an item here and we would retrieve an item back from here itself. And what was happening? This end was blocked. This end was completely jammed. But there are few differences from your stack and the queue. Okay, so we'll go ahead with the queue now. The first major difference here is it is a first in, first out. So remember friends, what would happen now? Just I will redraw the figure which I had drawn there. Okay, so this is my whole list. Sorry. Yeah. This is my whole list, okay, which we are dealing with. Yeah. What was happening in the stack? What was happening in the stack? You are entering like this. You are entering like this, right? This was my entry point. What was the exit point? Exit point was also here only, something like this. Yes. But what would happen in your queue? In your queue, when you enter like this, if you want to exit, you would be exiting from here. So that means, say for example, I have stored here 1. Yes, here I have stored 2. Here I have stored 3. And here I have stored 4. What did it enter first into my list? The first item entered was your 1. Right? What is which it is moving out of the list first? The 1 is moving out of the list first. So that means what now? First in. First in is what now? The first in is what now? It is 1. What is first out? The first out is nothing but what now? It is 1 itself. So therefore it is FIFO. What was happening in your queue? It was LIFO. It was LIFO. That is last in, first out. What is happening with your queue? It is FIFO. First in, first out. That means we are not blocked this end. We have kept it open. So whatever which enters would go out first, and whatever would so that means it is acting like your what? Anybody? It is acting like your pipe. Sorry for the bent pipe, a curved pipe. Okay friends, so what would happen in a pipe? If water enters at one end, it would directly go out in the other end, something like this. It would not go in the reverse direction, right? If it is blocked, if this pipe is blocked, what would happen if this pipe is blocked? If my water goes something like this inside, it will hit this blocked end and it will come back, right? So a blocked pipe is stack, a open pipe is your queue. That's all. So this would, I hope this would clear your all your doubts, right? Now that means a queue has both entry point and exit point, but whereas in your stack there was only one entry point and one exit point, but in your queue you have an entry point and you have a separate exit point, right? The next very important thing is all your new data would come and acquire the higher addresses, right? That means if I add any new data, what would happen? The new data would be acquiring the highest address, and if I want to retrieve the data, I need to go for the lower address. That's what we saw in that whole block, I guess. If you remember that whole block, the new data would be coming and sitting at the top. Yes, I'll just try to redraw it once again, just the block. The new data, where it would come at the higher address here. And if I want to remove the data, then where I should go? I should go at the lower address here. That's what it means in this point. Okay, now that means your queue requires how many pointers now? It requires 2 pointers. Which are the 2 pointers? One pointer here at the entry point, the other pointer is here at the exit point. Okay, so these are my 2 pointers, but in stack you had only one pointer, which would be here at the entry point, and the same would be your exit point. So therefore only one pointer would make my work. Okay, now this queue has some disadvantages. So to name a few disadvantages, you will have the first disadvantage, which is queue overflow. That means, what is this queue overflow? Now I have a queue like this. So this is my whole queue. Imagine there are some lines inside like this. Okay, some lines inside like this. Fine. So what would happen in queue overflow? If I go on adding data like this, so what would happen next thing? My length is how much now? Only this much. So this is my length of the whole queue. So if I add a new data, what would happen? This would increase like this. If I add one more data, what would happen? This would again increase like this. If I go on adding, what would happen now? The queue size is increasing. The queue size is increasing. So therefore, that means your queue moves in the direction of the higher memory, which we don't want. We don't want our queue to be overflowed. So therefore, in order to avoid this, we have a solution, which is nothing but which is called as a circular buffer. So what the circular buffer will do is, it will make 2 flags. One is beginning and another one is end. So one is here at the beginning, the other one is here at the end. So after every continuous time cycles, the last data, so this is my last data, right? So this last data will be erased out. That is, it will be removed. That means what we'll be doing now, we'll be removing this data. After some time, this data is removed. This is nothing but your circular buffer. That is, the last data would be removed whenever a new data would come. It is something similar like your, again, a recycle bin, you can say, or you can say a trash of your Google Drive. What would happen with the Google Drive trash? The last data which you have deleted would be removed after some time. That is what is your circular buffer, to understand in simple words. Okay friends, I hope the queue is clear. I'll stop the class here itself. Maybe you just go through these 2 classes in continuous, one wherein we discussed our stack in detail, the other wherein we discussed our queue in detail. Okay, we'll again meet in the next class wherein we'll try to discuss your subroutines. For now, you just try to concentrate on these 2 classes, and if you have any doubts, any queries, any time, you can just WhatsApp me on my number. So this is my phone number, where my WhatsApp number. You can just WhatsApp me and I would be available for you. Thank you for watching friends. We'll again meet in the next class.